Greetings and welcome to the Plsql channel, a series of video trainings on the Oracle Plsql language. My name is Stephen Feuerstein and I'm a Plsql developer just like you. This lesson is part of my series on error management in Oracle Plsql, and the focus of this lesson is raising exceptions. Some quick reminders. If you haven't already done so, visit my Plsql Obsession site at toadrule.com/sf to download all the code referenced in this presentation and all my other presentations, so you can run the same code, go through the same examples, and learn and really internalize the lessons that I talk about in the video. And make sure you're comfortable with the material covered in the previous lessons in the series, most importantly, defining exceptions. We take a look at the exception data type and how you can declare your own exceptions and how you can use the exception init pragma to associate your named exception with an Oracle error code or your own application specific error code. In this session, we're going to talk about raising exceptions. Now, of course, Oracle raises exceptions itself. It might run into its own internal errors. For example, you might try to remove data from a table and an integrity constraint precludes you from doing so. Or there might be a database in process of shutdown, all sorts of errors, and Oracle will raise them back to your Plsql block. But you can raise exceptions as well. And you can do so by using the raise statement and by using the raise application error built-in, which is used specifically to communicate application-specific messages back to your users. And we'll take a look at each of these in great detail. So first of all, the raise statement. You use raise to raise a specific named exception or to re-raise the current exception. You can use it to raise predefined exceptions, for example, one of the Oracle exceptions, or even one of your own user-defined exceptions. And if you call the raise statement with a semicolon after it, in other words, you don't specify an error name, then it re-raises the current exception, and as you'll see, you can only use raise semicolon from within an exception handler. So here are some examples. I declare my own exception by name. I associate that exception with an error number with the exception init pragma. I can raise one of Oracle's predefined exceptions. I can raise one of my own defined exceptions. And I can use raise semicolon to re-raise the same exception that was being handled. Now let's try it out in some real code. So again, I've declared an exception using the exception data type. I associate that exception by name with this error number. It's one of the Oracle date-related errors with the exception init pragma. I have a log error procedure which really does nothing but display the error. And then in my body of code, I will raise an exception in a number of different ways. I'll do a select into where 1 equals 2. That will force a raising of the no data found exception. I'll then raise no data found myself explicitly using the raise statement. I'll raise my own user-defined exception as well. Obviously, as soon as one of these exceptions is encountered, the other statements will not execute. So I'll run through them, go through them one by one. I execute my block of code, look at the output, and I'm seeing the number 100. And the reason I see that is that the no data found exception has an Oracle ANSI error code of 100, and also under some circumstances, -1403. So the log errors procedure, of course, the when others clause traps that exception. Log error gets the error code and it displays 100. So that's an example of Oracle raising its own exception internally, and there's nothing we can do about that except handle it and possibly re-raise it. I'm going to get rid of that query, and now I'm going to run the next version of this block of code. It encounters the raise statement, raises the exception, traps it, displays it, and once again we see error code 100. So you can see that's the actual same error as that which Oracle raises. Now I'll get rid of that one. And we'll raise my predefined exception, my own user-defined exception for bad date format. I run this code and I see -1830. So notice I raised the exception by name, but I also associated it with this number, so it shows me that number. If I take this line of code out, I simply declare the exception, but do not associate with an error number. Then when I run my code, I see error code 1. And that's the error code for all user-defined exceptions that are not associated via this pragma to another error number. Now notice in all cases I didn't see an unhandled exception because my exception handler caught all errors, displayed the message, and that's it, or displayed the error code. And that's it. It didn't force the raising of another exception. However, if I use raise semicolon at the end of my exception section, it will execute this code, and then it will say, wow, this is a bad error. I definitely wanted to log the error, but I need to make sure that the calling block or program knows there was a problem. In other words, I need to stop the application from continuing. So I run this code again, and now I get an unhandled exception coming out of my block of code. Notice it simply says Plsql unhandled user-defined exception because I didn't provide an error message for it or associate it with a different error number. And I'll still see the error code 1. If I go back and turn that pragma back on and run the same code, notice now it tells me that the error I've got is the negative 1830. So it automatically uses that error code and displays the error message associated with that code. But in both of these cases, the reason it did display an unhandled exception is that at the end of my exception section, I said, re-raise the current exception, whatever it is, just pass it back out to the calling block. The calling block could still decide that it doesn't care that it had this error. It might decide to continue. But at least from this level of your code, you've determined that this error should not be ignored. And it's up to the calling block to decide what to do with it. So there are several examples using raise. Now let's take a closer look at the raise semicolon. In other words, the re-raising process. So I create a procedure proc1, and it raises no data found. Proc2 calls proc1. Of course, proc1 will raise an exception, so proc2 also traps the exception and displays the error message associated with that exception. If you're not familiar with the format error stack function, this is discussed in great detail in the Handling Exceptions webinar in this series. Proc3 calls proc2, traps the exception, displays the error message. So let's run all of this code. I run proc3 and I see the following. Proc3 called proc2, proc2 called proc1. Proc1 raised no data found. So it comes out, traps the exception, and displays the error message, which is the no data found exception, re-raises the same exception, and then traps it and displays it here. Now, of course, notice I don't have to re-raise the same exception. I could say, well, I want to raise program error. I could run this code again, and now notice that proc2 traps no data found, but proc3 traps the Plsql program error. So you get to choose how you want to do that, which of those different errors you want to raise. Notice also that since I have two different exceptions, the no data found and then program error, I've created a stack of errors, and the format error stack actually shows me that entire stack here. And again, I talk about that in greater detail in the Handling Exceptions lesson. But the bottom line is that I can use raise semicolon to propagate the exception back out, which is what I had also showed you in the previous file. So that's what raise semicolon do. Let's talk about one of the complications of raise semicolon, or one of the restrictions, which hopefully Oracle will address at some point. Let's take a look at this program. Now in this case, my proc2 procedure has a local show error procedure. And the reason I've done this is that I have different errors that I want to trap for and potentially handle differently. So for example, for no data found, I might do some data recovery, some other specific different context and different action required for a different error. But in both cases, or in all the cases of my handlers, whatever I do before that, I want to show or log the error when I'm done. So show the error displays the error message or writes it out to a database table, and then re-raises the exception. And I'd like to put all these statements in this one procedure so that every place that I call it, I know it's doing the steps that are needed. It looks good, it makes sense, but sadly it will not compile. I try to compile this code. Let's get rid of that undefined procedure. Try to compile this procedure, and it tells me that the raise statement with no exception name must be inside an exception handler. What you see here is a weakness in the Plsql compiler, at least that's my viewpoint. Show error is only called within an exception handler. So in fact, the raise semicolon is only executed in the context of an exception. But the compiler doesn't recognize this. The compiler is insisting that if you want to reference raise semicolon, raise without a named exception after it, like ABC or no data found, if you want to say raise semicolon, you've got to do it inside the exception handler explicitly. So I have to move raise out. Now my procedure will execute, will compile, and now I can use it. Unfortunately, I have to repeat that logic in all my exception handlers. So I'm hoping in some future version the compiler gets a little bit more sophisticated, so at least in a situation like this, where show error is defined within the context of this procedure, and it can tell that raise semicolon is only executed within the context of an exception, that it will not give us this error. But in the meantime, you will have to put raise semicolon in each one of your handlers if re-raising is what you want to do. Okay, so that's raise. Now let's take a look at communicating application-specific errors and the raise application error built-in. Obviously, when Oracle raises its own exception, it provides the error code and the error message. Unfortunately, that's not often good enough for us when we want to communicate back application-specific messages to our users. For example, suppose that an update is being made to an account, and the account balance has fallen below the minimum, let's say of 100. We want to notify the users that a problem has occurred. Well, if I say raise program error or raise no data found, it'll simply give me this generic Oracle error message, which is not going to be good enough. So I need a way to communicate back to the user all the necessary information they need to understand what went wrong and potentially how to fix it. And this could involve an error code. Most certainly it should involve an error message, and maybe both. And to handle this scenario, Oracle provides the raise application error built-in. So let's take a look at how you can use this built-in procedure to define and raise and pass back application-specific messages. So you can raise an application-specific error with raise. For example, going back to my previous piece of code, I can define my own exception. For example, I could say balance too low right here. And I can even give it a number like minus 20,800. We'll talk about what that range means in terms of application error in just a moment. And I can then raise this exception. And let's go back and show not only the error code, but the error message. So I'm going to raise the balance to low exception. I'm going to trap the error code, display the error code, and display the error message. And I don't need to re-raise here. I run my code, and here's what I see. The error code is negative 2800, and the Oracle error message is nothing, negative 2800. So I wasn't able to pass back in any way, shape, or form the fact that this was a balance too low error. All I could pass back was the error number. So using the raise statement in this kind of situation is simply not going to be good enough in terms of communicating valuable information to our users. So instead, we use raise application error. So with raise application error, you can essentially construct your own error messages so that when any piece of code in the Oracle environment, your code, the front-end code, calls SQL code, calls SQL error message, calls the format error stack, it will return your values, your error code, your error message, not those of Oracle. And then, of course, this information can be displayed to the users, or it could be sent to the error log. Let's take a look in more detail at the raise application error. We'll start with an example, then we'll explore some of the nuances of this built-in. Here's a very typical usage of raise application error. It's inside a database trigger, which is often where we need to raise these kinds of errors. The user has entered some data. I need to save those changes, but there's something wrong with what the user entered. And I want to put the validation for this data inside the trigger so that no matter how this table is being updated, we can trap bad data. And the specific rule that I'm checking for here is if the birth date of the employee is more recent than 18 years in the past, in other words, if they're less than 18 years old, they're not a valid employee. You have to be at least 18. So I need to stop the update or stop the insert, and then pass back the error information. Well, I can raise an exception inside my trigger with raise, and it will stop the update. But how do I let the user know what the problem was? In this case, what I'll do instead is use raise application error. So with raise application error, I specify an error code and an error message. And these are the two values that Oracle will put inside its memory register for SQL code and SQL error message, so that when I call those built-ins to get my error information back, it returns this information. Now notice in my little explanation here, I say that this is a typical usage and also a typically problematic usage of raise application error. And the problem with this use of raise application error is that it involves a lot of hard coding and redundancies, essentially. I hard code the error number, I hard code the error message, I've even hard coded the business rule, though that's not specific, to raise application error. And unless you're very careful about how you use raise application error, you will end up with a lot of hard coding. Now I have a separate lesson on best practices for error management that I suggest you watch after this one, and I talk about the problems of raise application error and how to avoid these problems. In fact, giving you some recommendations on how to avoid using raise application error at all. But it certainly is an important built-in to know about, so we'll continue with the instruction here. But do make sure you check out best practices where I talk about avoiding these hard codings. So let's take a look at the employee must be 18 script. So I create my employees table. I create a trigger on that table saying, as I mentioned before, if the birth date is more recent than 18 years in the past, raise application error. Then I'll try to insert a new employee into the table whose birth date is, well, right now. A newborn baby is going to be the employee. Let's see what happens. So I'm going to run my code. The log error procedure will simply display the error message, and then we'll re-raise. Create the table and trigger. And now when I try to do the insert, the error stopped me from continuing. And notice it says ORA negative 20,070. Employee must be 18. So it was able to communicate out both the error code and the error message. And now the end user can see this information and be told, oh, that's right. This is not a valid date. I need to change it. Now, if instead of using raise application error, I used raise no data found, for example, I rerun the same code. Notice that the update did not take place, or in this case, the insert did not take place. So it was invalid. The trigger did stop it. But the information I get back is not specific about the situation, and so I lose that information. The user loses that information, and it's a lot harder for the user to work with the application. So that is the key advantage of raise application error. It allows you to propagate this error message back to your users. Some details on raise application error. In almost every case when using the raise application error built-in, you will have just two arguments, the error code and the error message. It turns out there is a third argument, keep error stack, and the default is false. And that determines whether or not you want to keep the entire stack of errors when the error message is displayed. Now, first of all, the raise application error built-in is actually defined in a package called DBMS standard. It's one of the two default packages of Plsql. That means that you do not have to type DBMS standard dot raise application error, though in fact you can, just to demonstrate that to you. This is also a valid call to raise application error. And when I run this code, notice I get the same behavior. But in general, you don't prefix these built-ins with the names of the standard or DBMS standard package. Since it's a default package, Oracle will look for something named raise application error in your current schema or your current block of code, and if it can't find anything, then it will automatically use the one that's in DBMS standard. So it's a bit of Plsql trivia. It doesn't matter really in your code, but it's good to know how this technology is implemented under the covers. The num argument, which is the error code, has to be a number between minus 20,099 and minus 20,000, which is really unfortunate. It's a very arbitrary range of values. We certainly have run into customers, users of Oracle, who have run out of error codes in this range. It's only 1,000. And if you try to use something else, you get an error. So if I try to use 22,000 and run my code, error number argument to raise application error is out of range. So you can't use that value. So you're stuck with this specific range of values, which for most developers is not a big deal. And error messages can be up to 2048 bytes. Now this is kind of weird. You can actually pass a string of up to 32K to raise application error, but it will essentially ignore almost all of that stuff. The users will not be able to see the full string. That's, I think, quite unfortunate. Hopefully they'll fix it at some point. And again, the third argument determines if the full stack of errors should be returned or just the most recent, which is generally speaking what you're interested in, and that's why it's the default. Let's go exploring. So here are some examples of using the different error codes. Here's the minus 20,000, which is probably the most common error code used. Sometimes everybody just uses minus 20,000 for everything. And when I run this code, I see minus 20,000, balance too low. I can, of course, pass in other values in that range. For example, the largest negative allowed, minus 20,999. And again, I'll see that information. Minus 20,099, balance too low. If I try to use a value out of scope, if I try to use a value that's out of the range, as I showed you just before, I will see an Oracle error. Minus 21,000, so they use the number just outside of the range to say this is not valid. Invalid range. Actually, I'm sorry, that's whatever number it is, I believe. So if I change this to negative 22,000, no. Okay, that was just a coincidence initially. Minus 21,000 is an Oracle error that is specifically telling you that it's out of range, and it shows you the out of range value here. And finally, if I try to use raise application error with one of the predefined exceptions, so here's the negative 1403, which is the no data found exception, I get the same error. This is out of range. So that's the first thing to remember about raise application error. You've got to use a number within that range of minus 20,000 to minus 20,999. And in general, the best practice is to create a table that has all your predefined errors, store them there, and then reference them by name again. This is covered in the best practices lesson. Now let's take a look at the issue of the maximum length string, and then we'll take a look at the use of the full error stack, or keeping the full error stack, or rejecting it. So the maximum string length. Now, here's a piece of code. Let's pull out this one anonymous block right here. What I'm going to do is, inside a loop, using actually a goto. I know you're not supposed to use it, but they're fun to use now and then. So what I'm going to do is construct my string that I'm using in raise application error character by character and see how big it can get. So I raise an exception. I trap the exception. If it's minus 20,000, which it would be for this one, then I go to raise application error and do it again. Add a over and over and over again. So at some point it will hit the maximum, and then we'll see what the maximum length is, because the error that's being raised is not minus 20,000. I run my code, and it shows me that the maximum length for raise application error is 32,766. Let's go back here and do one other thing. I want to show what the error actually is. So we'll display the format error stack. Run it again. And why did that happen? Let's see. Oh, because this is not where the error is being trapped. It's being trapped down here in the outer block. So let's see. Run it again. And it tells me that the error, the actual error that was being raised, is the -6502. In other words, the string got to be too big, and then it trapped the exception and displayed it. So the maximum length is 32K. And you can pass a string that long, but the question is, what will you do with it? Or what does Oracle do with it? So let's take a look at this block of code. Now in this case, what I'm doing in a single statement is declaring a really big string, 10,000 characters long. I call raise application error with that string. Then I'll display the length of the error message and the length of format error stack. These are the two different mechanisms for getting the length of the error string. I run my script, and I see 510 and 1899. So first of all, notice that both of these numbers are well below 10,000. In other words, my error message was 10,000 characters long. Raise application error let me run that. In other words, it did properly raise the exception, in which I trapped the exception. However, it does not give me access to the full length or the full the full error message that I had passed into raise application error. And depending on which of your programs you're using to get the error message, it might show you a very small part, a truncated message, or a longer message. And again, I cover the nuances of the different sizes of your error messages in the section on handling exceptions and looking at all the built-in functions to retrieve the information. But the bottom line is that whichever way you go, format error stack or SQL error message, you will not be able to retrieve the full length of the error information. So Oracle has truncated it before you can even get to it. Now notice the length of 1899. That's quite different from Oracle's documented maximum of 22,048 bytes. So that's what it says in the documentation. Turns out that's not really true. The bottom line is that you can't have arbitrarily large error messages, but in most cases this is not going to be an issue. Your error messages are usually not going to be so long because it's very hard for your users to read them and understand and make sense of what they should do. So on a day-to-day basis, I doubt this will have an impact on your lives as programmers and the experience of your users, but it's certainly good to know about. Finally, let's take a look at the error stack issues. So what I'm going to do here is have proc1 raise no data found, have proc2 call proc1, trap for any error, and then raise a different exception. So propagate out a different exception. I'm transforming no data found to dupe valid index. And then proc3 calls proc2. Proc3 traps the exception, calls raise application error, and shows me the topmost error message. And notice I have keep error stack set to true. And then I'll run it again with keep error message set to false, which is the default. So first of all, let's try it with keep error stack set to true. Clear all this out, run my code, and I see the following. Here's the error stack. It's a formatted error stack, and it shows me that the first exception, the bottom of the stack was no data found, that was changed into the -1, the dupe valid index, right here. And that in turn was turned into the -20,000 error with raise application error. So if I use true, if I include true as my third argument, it will keep all this information in the error message that's displayed or stored, which is great because I can see the full stack processing. Of course, for end users, that kind of stack is usually not very interesting. So the default behavior for error stack, for raise application error, is a value of false. So let's redefine proc3 to say don't keep the error stack and run it again. And here's what I see. Rather than the full error stack, with keep error stack set to false, it just shows me the topmost error message. And the fact that a no data found was raised, then a dupe valid index was raised, all that information is gone. I don't care. I just want to know about the most recently raised exception. Again, that's the normally expected behavior. You can change it if you want, but it is the default. So the way that raise application error is almost always called is like that, and we should see the same output. There we go. So if you're ever wondering where all your error stack information is and you're using raise application error, just remember that you might want to add that third argument to say keep the error stack so I can get that full error information, put it in my log, and so on. So some conclusions. You can raise Oracle exceptions. You can raise your own predefined application specific exceptions with the raise statement. You can use raise semicolon to re-raise the current exception, but you can only do that inside an exception handler. And I've heard some indications that this may be fixed in Oracle 12, but of course, no verification, no confirmation. I'm just hopeful that that will happen. That will give us a bit more flexibility. So today, all the way through Oracle 11G, raise semicolon can only appear inside an actual exception handler. When you need to pass an application-specific error message back to the host environment, back to the user, you cannot use the raise statement. You will need to use raise application error. And just keep in mind that you have to specify a specific error code in the -20,000 range, the error message. You can decide whether or not to keep the error stack. But in general, try to avoid the hard coding of those error codes and error messages. Take a look at the best practices lesson on error management to learn about some ideas for doing so. But in any case, if you need to get that error message back to your users, use raise application error. It's a fine mechanism for doing so, and it'll give the users much better information, much better way to decide what their next step should be in their application. So, next steps. Obviously, go back through this video, pause at the pages with the code examples, run the code yourself just like I did. Make sure you understand all the nuances of the code as demonstrated here. Then you'll be able to put it to use in your application much more effectively. And then I suggest that you move on to the next webinar in the series on handling exceptions. Because raising exceptions, certainly it's good to know about, and you will occasionally raise your own exceptions. But for the most part, Oracle will do the raising for you. When it comes to handling exceptions, however, that's where you need to have all the details. You're going to write the code to get the information out about the exception and decide what to do about it. So it's a very critical lesson, and hopefully you'll learn a lot from it. So thanks for joining me, and best of luck in your PL/SQL coding, and hopefully you'll be listening to me again soon.